So part D, here are the heights for a sample of 200 girls aged 3 years and 0 months. Evaluate whether the normal distribution you calculated in C is a suitable model for this situation by discussing the distribution features of the sample. So the first thing we have to remember is that in part C we worked out that the mean was equal to 95 and that the standard deviation was equal to 3.7. So here are the features of a normal distribution that you need to know. Firstly, just use my pen. Firstly, it's bell-shaped. That's the first thing. So it has that kind of look to it. Okay, half is one side of the mean and the other half is the other side of the mean, and that the mean, the median and the mode are all the same. Okay, so the mean, median and mode are the same. What else can we tell? It's continuous data, but it can also be discrete, but can be discrete. Okay, it's the standard normal, 99% or about 99.7% of it or so is within 3 standard deviations either side of the mean. Okay, there is no skew, as it is symmetrical about the mean or about the center. Okay, so there's some basic factors about a normal distribution curve. So what we need to do is try and apply some or not apply some of these to the set of data that we've got in front of us. Is it bell-shaped? Well, you could argue that it's kind of bell-shaped, if you see there, and you know, I've drawn the peak roughly at 96, even though you've got this high value here. If we drew a 95, is it symmetrical about the mean? Probably not quite. So sort of symmetrical about the center, but it looks like, however, it looks like the mean of this data is about 96, centimeters, which is a bit higher, than 95 centimeters. Might not seem a lot, but that's quite a bit when you think the standard deviation is 3.7. Now, thinking about the standard deviation up here, what we can do is we can say, well, we've got 200 girls that are aged between in this variable here. Now what we can say is we can go, well, if we had a mean of 95, okay, with a mean equaling 95, if we go plus or minus 3 times the standard deviation, which is equal to 11.1, we get a 99% range of between 83.9 through to 106.1. So if we go on to the graph, here's 106 and there's, well, 83.9 is 84. So we're talking, like, you know, apart from this set of data here, which looks like it's one value out of 200, that's pretty close. That's pretty close to what's happening. Pretty close to a normal distribution. Okay, it's pretty damn close. We could go one standard deviation either side and count up the values, doing our best. You could do that. One standard deviation either side would be from 91.3 through to 98.7. So if we went from 90 through to 98.7, or in fact if we went 91.3 to 98.7, one other thing we could do is let's have a look at, say, what the data gave us between, say, 90 and 100. And if I did that on my calculator, worked out the probability of x being between 90 and 100 using the normal distribution with a mean of 95 and a standard deviation of 3.7, I get that equals 0.8234. Now I could compare that by counting up each of these values and working it out as a total between each category. So what I've done here is, you can see I've just added onto the graph the heights of each of these columns. So I figured that out to be about 8, that the 92 to 94 to be 56, 94 to 96 to be about 40, 96 to 98 about 22 if you look at the scale here, and this other one 38, and then I added them all up and they all added up to 164. Then if I divide that by the 200 students, it comes out at about 0.82, okay, which is very similar to what I've got down here. So I would say that as well is a good indication that this, even though it doesn't look like a normal distribution, certainly some of the numbers do add up. It's 164 over 200 equals 0.82. So I would say these are a couple of features that certainly indicate that this could be possibly matching a normal distribution. So that's probably all you need to do there. If you said one reason, so one reason gives a U, two reasons gives an R. That this is not an excellence question. So basically there, I mean, sometimes this might, if they'd given a third reason, some papers might have got you to excellence or something like that. But if you can give two reasons plus some justification, either it being some information based on this list up here, okay, or some calculations like I've done down here, that's enough for this question.